Okay, in this video, like in the earlier one, I wanted to show you the image of a certain region under a complex valued function. This time it's not going to be just a circle, this little patch. It's like this entire region, and these vertical lines and horizontal line will give us some idea what kind of transformation is done into this part. Alright, let me start like this again, the exponential function, and this show box is going to be the size of the entire thing we're going to be looking at. And this eventually I needed it to change a lot, so I named it. This x min and x max is going to be the x minimum value of that patch, rectangular patch. Wanted to look at x min value and x max value here, y minimum value, y maximum value. These three are the number of lines I wanted to put in between. So starting from 1, 2, 3, things like that. So I realized there's no need to change that number that much, so they can set it to equal. So those are some of the setups. Like last time, I named this conversion of complex number to xy coordinate system like this. And next thing I'm doing here is calculating x coordinates of these kind of marked indicate the points in between that I wanted to draw a line across. And here's a y coordinate. So x values start from x minimum and end up at y x maximum, and I have to determine the increment, which is calculated like this: difference divided by number of line I want. So that will be the increment, and I put this 1 point multiplied, so that is all. These are all numerical, and it Mathematica calculates a little bit faster with the numerical values. Right, this is a parameterization. Before, an early example was a circular parameterization, but it's rectangular going up and down. It's a lot easier. And if I fix s in here and vary t, that would be a vertical line. If I fix t and vary s, that would be a horizontal line. So the parameterization involves two things. And here, when I'm doing this, I'm going to play with the t, with s, and so on. So realize that if you define it as a two-variable parameterization like this, is convenient. And this is image of this domain z value going under the complex function f, and it's going to calculate. This part in here, we have these complex version and turning it into an xy coordinate version in here. And next part, I like this part of the Mathematica, is a map function. We're going to plot bunch of vertical lines in the domain z value, vertical lines. The vertical line with the parametric plot of while t is varying and s is fixed. Right, you fix s, and t is varying from y min to y max. That would be this sort of vertical lines. But each time when you do this parametric plot, vertical line, this location of this vertical line is coming from the x values you calculated. So these are the x values across. You put it in there and fix it, and do the vertical line with the t. And you collect all of them in here. It's a quite convenient command. The horizontal line will be changing this first coordinate and fixing the y coordinate. And this y coordinate is individually coming from this y value. So that will collect a bunch of vertical lines and a bunch of horizontal lines. And I'm doing the same thing with the image. I'm not using the z path, but it's image of the path, and s and t are varying exactly in the same fashion. And this command image path will take care of this vertical and horizontal straight lines. Is going to be some curved line as it goes through this command image path xy. But it's Mathematica command structure here is exactly the same. Now, like the last time, I'm going to show this nicely together. The vertical lines and the horizontal line all put together into one picture, and that fills up the first part of the grid, and image pod and fill up the second part of the grid, and that's going to show you, image domain in here and image there nicely. All right. So when I ran it, it's a domain. It's centered around -1 to +1 with the three areas, regions below, and it kind of shows you what happened to that perfect nice rectangular plane under this exponential function. It's kind of stretched and turned around like this. Well, of course, we want to name this procedure and change this kind of location of x min and y max, so that when I put the patch over there, it tells you what happened to this part of the domain under this function and things like that. So like the last time, what you have to do is go this part and name this entire procedure like this sketch image, and usually the function is a variable, and this x min, so I typed it in, all the x min, x max, and number of lines in between x, y min, y max, number of lines in between the y, those y coordinates. If I give you this much, the rest of the part is exactly the repeat, it goes to exactly the same way. But you better declare the local coordinates, local variables here in the commands. Now I listed all of them, so all the command you use in between all change the screen color, and at the end, and you close it and run it, then now it's a sketch image. Now it's ready to run. So I'm going to show you typing sketch image of the same function before, -1 to +1, 3 lines, and -1 to +1, 3 lines in between, and that's going to do exactly the same picture. If I want to change that to, let's say, -2 to 0, something like that, then you can see that switch a little bit and then change that a little bit like that. And of course, at this stage, you want to change this one continuously so that you don't have to keep typing back and forth. You want to do this in a much nicer way. So that's manipulate, and you go manipulate and change this left end. Maybe that's going to be xm, and that if I keep the distance 2, that was -1 to +1, that was distance 2, so I'm going to keep this distance 2 like this, right? xm, starting from xm, end up in x2. Let me keep this number of 3 exactly that way. Ym is lower, and ym +1 will +2 will give you distance 2. Now all you have to change is that you want to vary xm, then it's automatically it's going to create this slider, and so you can vary it. So for example, if I go from -4 to +4, I'm going to change the 3 to +3, and ym -3 to +3 seems like it's going to fit in. If you do that, it's going to create a 2 slider. So x starts at -3 to +3. So if you move this one up, you can see it changes to x coordinate. If you move this one up, it go up. So you can use this 2 slider. You can locate this rectangular box anywhere you want, and it is telling you what is happening to this little grid under that function, exponential function. So this is pretty neat. Of course, there's different options of a slider, so that you can use this 2-dimensional mouse movement that adapt to that. But this is the simplest way you can use and learn. If you choose manipulate slider options, there are things that you can choose. So this is a wonderful way to see what the function is doing to that, especially the function is discontinuous. That's the part that's rip apart. So let me show you how to actually do that, and hopefully you can use this entire procedural command that is available here to investigate your bonus problem. So now I copied it down the function, and so you can change the function nicely. So if I do z squared -2 minus z, that I think I did it before, then you can see it does something crazy in there. It's very difficult to see what that thing is doing with this just three of them. So if I change the number in here, maybe it's going to show something better. And I think this is going too crazy, and maybe right, I changed to something manageable. I always wanted to see what happens with the cosine z, so I did the cosine z. Let's see if you go over there. It's about the same thing, but something weird is happening around there, around the real line. The cosine is oscillates and things like that. So something like that is going, especially around the real axis. Something funny is happening. That's kind of understandable because we know how the cosine function looked like in there. So hopefully this gives you a good investigation tool. But the one that is not continuously ripping things apart was just log. So I want to try logging in there, you know the negative real axis was a problem. So if you raise it up there, you can see this is ripped apart, right? This top part is ripped apart there, and bottom part is ripped apart there. So that's as an animation, that's a problem. But if you stop moving the slider, it shows you how things are ripped apart. It's pretty fun to see. If you move it slightly to the right, and that part is moved apart. If I go over there, and it's kind of in the process. This part is not ripped apart. Only that part right there is ripped apart. Something like that. So if I want to see better, right, I changed the number of points in between the two 10 and 10 in here so that you can see slightly more the detail of how these things are ripped apart. And probably these two part is a solid part over there, and it's confusing. I think this is the part where it's being ripped apart right there and right there. It's pretty fun.